The second major topic we are covering today is that of lines. We will talk about the slope of a line, talk about a couple of different equations of a line, point slope form and slope intercept form, talk about how to know whether two lines are parallel to each other or whether they are perpendicular to each other. So the first thing we have to do is talk about the slope of a line. So in class on Monday afternoon, we used capital M for the midpoint between 2 points. Now for slope, we will use a lowercase m. And we're still dealing with subtracting 2 y components and 2 x components. Now there was a question in class as to whether or not the order mattered. When we used the distance formula, the order of our subtraction didn't matter. In the midpoint formula, we just added the 2 coordinates and divide them by 2. In the slope formula, which coordinate goes first, whether it is x2, y2, or x1, y1, that part doesn't matter. What does matter is that whichever y coordinate goes first in the numerator, the x coordinate that goes with that must also go first. So I'm actually going to find the slope between the 2 coordinates that we used in class on Monday. I believe they were points -1, 2, and 3, 4. So the slope between these generically doesn't matter whether I put the 4 first or the 2 first. If I put the 4 first in the numerator, I must put the 3 first in the denominator. So the 4 is the y component that goes with the 3. The 2 is the y component that goes with the -1. So 4 minus 2 is 2. 3 minus -1 is 4. And we reduce all of our slopes to put them in lowest terms. We can then take this slope formula and actually multiply both sides by x2 minus x1 and get what is referred to as point slope form, where we have y minus y1 equals m times x minus x1. Here, instead of having 2 subscripted variables, we actually only have 1. So this y1 and x1 are going to be specific numbers, and m is going to be our slope. What's nice about this is as long as the x and y coordinates are on the line with this slope, it doesn't matter whether we say we picked the -1, 2 or the 3, 4. So if I wanted to put this equation, or the equation between these 2 points in point slope form, I could do y minus 4 equals 1/2 times x minus 3. The slope between the 2 points is 1/2, and then one coordinate on the line is the point 3, 4. What we're ultimately wanting to end up with is slope intercept form. This is the probably familiar y equals mx plus b. M is the slope, b is the y-intercept, so that's why it's the slope-intercept form. We can take this point slope form and solve it for y to put it into mx plus b form. So to do that, we must distribute the slope across the x minus x1 to get y minus 4 equals 1/2 x minus 3/2. Then we must add 4 to both sides. On the left, we will have y isolated by itself. On the right, we'll have 1/2 x minus 3/2 plus 4. And here I'm going to write 4 as a number whose denominator is the 2, so that we can actually add like terms. To get the line between these 2 points in slope-intercept form is y equals 1/2 x plus 5/2.